Okay, so our next topic is going to be temperature on Earth's surfaces, which is the lab we just did. We just modeled temperature on land versus temperature on water, and we learned that land gains and loses heat faster than water, right? Okay, so let's write that down. So different surfaces gain and lose heat at different rates. Different surfaces gain and lose heat, okay, at different rates. That's going to affect your weather. We'll talk about why. So the two biggest points we got out of our lab data is that land heats faster than water. Okay. And the second point we got out of our lab is that land cools faster than water as well. In other words, it loses heat faster than water. Okay. Heat is gained and lost. Okay. Cold does not. So, for example, if your bedroom is really hot and you open the window, okay, the heat leaves. Cool doesn't come in. Heat leaves. Okay? Heat is what's either coming or going, depending on if it's being gained or lost. Okay? All right, for this next part of the notes, I just want you to put your pencils down and watch and kind of follow along. And then when I'm done, I'll give you time to copy it. Okay? But if you're trying to copy and listen at the same time, sometimes we lose it a little bit. All right? So right now, I just want you to watch. All right. We're going to talk about how land heating up and cooling off faster than water affects land and water in the day and in the night, right? Because in the day, we have a source of heat. We have the sun's up. But at night, that sun goes away, okay, and things start to cool off. So we're going to talk about the differences that cause, basically, okay? So we're going to start with during the day. So like I said, for this part, I just want you to watch. So during the day, in other words, when the sun is out, okay? So I'm going to set up my scene here. I'm going to have some water, okay, next to some land. That land could be sand or not. It doesn't have to be sand, okay? This doesn't necessarily have to be a beach. It could be like a pond next to the timber. It doesn't matter, okay? But because it's during the day, the sun's out. So we have a source of heat here. Okay, so when it's daytime, who's warmer, land or water? Land, right? Because we learned in our lab that land gains heat faster than water does, right? So your land is going to be warmer, okay, versus your water is going to be cooler. So warmer land, how is that going to affect the air above that land? What's going to happen to the air? What happens to the air above this land? It gets warmer, right? Because it's warmer, so it's going to transfer its heat to the land, right? So the air above the land is going to get warmed, okay? So the air is warmed, okay, by the land, okay? And when air is warmer, what does it do? It gets less dense, so what does it do? It rises. Very good. So this air is going to start to rise. Now, the farther away it gets from the land, what happens to it? It cools off, right? Because it's no longer by its source of heat anymore. So the farther away from the land it goes, the more it's going to cool off. So your air cools when it is away from the land. Okay. And when air cools, what does it do? We have to understand what happens when matter gets warm and when it gets cold. So you tell me, what happens to air when it cools? It gets colder, so it gets more dense, so it sinks. Okay? It sinks. Okay? Now this air here is leaving, isn't it? Because it's rising. So this cool air is going to rush in and take its place. So if I'm standing right here on this land, okay, what am I feeling? Air is rushing at me. What am I feeling? Wind. Am I feeling wind? Okay, so the cooler air is right here is going to replace this warm air. Okay, and it's going to rush in and replace this air here that's leaving. And it's just going to make this constant cycle. Because then once this cooler air goes above this warm land, what's going to happen to it? Once this cooler air gets above this warm land, what's going to happen to this air? It's going to warm up. Warm air does what? Rises. What happens when it gets away from the land? It's cool, so it sinks, and it just keeps going in a cycle. You see how that works? Okay, this is called a sea breeze. Okay, because the wind is coming from the sea. You see how that works? It's coming from the sea or water source or whatever, but it's coming that direction. Okay, so now let's change it up. Okay, what happens during the night? Okay, now we're going to write what happens. So I'm going to set it up the same. We're going to have water. Okay, we've got land. Okay, and instead of a sun, I'll draw the moon, okay? Just to symbolize that it's nighttime. Okay, so at night, who's warmer? Land or water at night? What happens to land when you take away its heat? It cools off quicker, doesn't it? So who is warmer, water or land? Water at night. Your land is going to be cooler. So what happens to the air above the water? It's warmer, Alfredo. What happens to the air above the water? It gets warmer. Okay, so your air is warmed by the water. And when air is warmed, what does it do? It rises. Once it's far away from its source, though, what happens to it? It gets cold, so your air is going to cool. Yes. Okay, and when it cools, you guys already told me, but then it sinks, right? And then it's going to replace this air that's leaving, isn't it? Okay, so the cool air replaces the warm. Okay, rushes in here to replace. So what way is your wind going now? From where? Is it like up in the, during the day it was a sea breeze, right? It was coming from the sea. So now where's it coming from? Coming from the land. So what do you think it's called? A land breeze. Does that make sense? Okay, good. All right, now you can copy it in your notebooks. I'll start with during the day.